my name is Alejandro, and welcome back for day 101 of me doing the Daily LeetCode challenge. Today I reach 1 year's worth of green contributions here on GitHub. So today's problem is for October 25th, 2024, and let's get straight into it. Okay, today we're going to get LeetCode medium, problem 1233, remove subfolders from the file system. Okay, given a list of folders folder, return the folders after removing all subfolders in those folders. Given a list of folders folder, return the folders after removing all subfolders in those folders. Okay, you may return the answer in any order. If a folder I is located within another folder J, it's called a subfolder of it. A subfolder of folder J must start with folder J followed by a slash. For example, /A/B is a subfolder of /A, but /B, okay, so it's just Linux things. But /B is not a subfolder of /A/B/C. Yeah. /A/B is a subfolder of /A. Makes sense. But /B is not a subfolder. Yeah, sure. The format, but can it be a nested subfolder, right? The format of a path is one or more concatenated strings of the form /. For example, /GitHub and /GitHub/problems are valid paths, while an empty string and / are not. The format of a path is one or more concatenated strings of the form / followed by one or more. Okay. So here, so folder.length. So yeah, this is our list of folders. There's a most 10 to the 4, so an n-squared solution, even if, I don't know of an n-squared solution so far, but even if there was one, that doesn't work. Okay, each folder is up to 100 in length, which is interesting, which means that we can do the number of characters times the number of folders in there. Because this is 10 squared times 10 to the 4, 10 to the 6, that's legal in LeetCode. So very, very interesting. Folder of I contains only lowercase letters and /. Folder I always starts with the character /. Oh, it always starts with a /. Okay. Oh yeah, from the root. Each folder name is unique. Okay. Return the folders after removing all subfolders. Okay. So let's look at an example. So here we have /A/B/C/D/ Wait, what? Do you just remove the? Oh, wait. Okay, folder /A/B is a subfolder of /A. I see. Maybe this is a tries problem, right? Where it's like, is it a prefix of another and like the full, okay. It could be something like that where it's like I ignore the slashes maybe? Oh, no. Because then I have words, I don't have letters. So maybe it's not a try problem. Okay. Let's think. /A/B. /A/B is a subfolder of /A. And /C/D. Actually, no, maybe it is a try problem. It's just that I include the slashes as part of the letters. And then it's like, okay, for something like /A, then I look at /A/B, and then I see, does that work? Okay. Maybe it's like, yeah, but do I need to do like 2 parses? Okay, I gotta think, right? Folder /A/B is a subfolder of /A, and /C/D/E is inside a folder /C/D in our file system. Right, so it's like you're given a list of folders. If any of the folders is a subfolder of another folder in folders, can we do something like, I put all my folders into a hash set. Then for each folder, I essentially compute its daddy, right? So one thing, this is a good example, right? /A/B/C. Okay, so yeah, this is considered a subfolder of /A. Okay, so it's not that trivial, because one thing I was going to say is like, for every single one of these, compute its direct parent. Like the point with something like this, right, is you want to check like, okay, is /A in my solution, right? Otherwise, is /B inside of my solution, right? Otherwise, I get to keep this guy. So, if for each folder I go through its whole length, actually that'll work, right? Because this is 100. So if for each folder I go through its full length to determine if it is like, a subfolder of another, and I do that for each folder of which there's 4 times 10 to the 4, then I'll essentially have 4 times 10 to the 4 times 100 in the worst case, which is equal to 4 times 10 to the 4 times 10 to the 2, which is equal to 4 times 10 to the 6. And this on LeetCode should be a passing solution. And then we can see, oh yeah, okay, and there's like 70% accepted and so on. So maybe it is just that simple, right? We can just essentially do something like that, right? So the very first thing we're going to do is we'll do a folders is equal to set of folder, right? I don't know why they list of folders folder. Oh, okay, we might as well make the folders a hash set, right? Now our result is going to be an empty list. For folder in folders, I don't like that it conflicts with this name, but oh well. For folder in folders, we want to check if it's a subfolder of another, right? So like something for like /AB, we want to first check like, is /A in there? And then we want to check if /B is in there, right? Maybe I split them. Maybe I split them as tuples, right? Where it's like, okay, let me whip out my terminal here, right? Let's do something like this. If I do A/B/C and you dot split on this guy, that's interesting, right? For each one, so in total, I might get to the 10 to the 7 threshold, which starts getting really slow. But I could make everything, like this so that it's very nice and convenient. Huh. I don't know. Okay. Well, initialize our /index is equal to 0. I is equal to /index plus 1. While folder of I oh gosh, maybe here I do split it, right? It's like I want to parse it with a like here it's convenient that they're just letters, but okay. I mean, since they're at most 100, it's fine, the idea that I want to do, right? Because in terms of running time, 4 times 10 to the 6 is completely acceptable on LeetCode, right? So that's going to be totally okay. It's just I want to get to the point where it's like, okay, let's try not to get too inefficient, right? Because this is where you start getting to the territory where it's like you get on the borderline between TLing and not TLing. Like I think 10 to the 7 sometimes is okay. 10 to the 8 is definitely not okay. So it's like you're starting to like, tread on thin ice when you get to these kinds of numbers inside of LeetCode, right? So I'm wondering how efficient our idea is, right? So here's really you want to play with the numbers. Maybe I do split everything because it makes things convenient. But that's like I can only hash tuples. Yeah, it's just kind of annoying, right? /A, like I know what I want to do, but I want to do it in an efficient way. It's like I don't want to keep making, subcopies of the same string over and over and over and over. Because then it's like I get into like, the 100. Like if I square this 100, It's like, this becomes 10 to the 4 times 10 to the 4, like that's not okay. So I need to find a way to do that efficiently. Like a one ways would be like, having the letters inside of a list and like a collections.deck, but then the whole thing isn't necessarily hashable, right? Maybe it's like I hash all the tuples and then I still go on with the lists. But again, it's like even if I do 2 times this, it's like I'm starting to tread on thin ice, right? In terms of computation capabilities. So it's like I gotta be very careful, not to like usually it's like O of n is the same as 2n, 3n, 4n, 5n. Here I cannot just start doing like a 4n solution and so on, because it's like I start getting into that TLE range. So okay, I gotta make sure that I do this like as efficiently as possible. If I do something like this, it's kind of annoying. Right? It's like I can't really necessarily cache results either, right? Because again, I have to make the same sub work. The point is, it's almost as if though this is a fully cached result. So okay, this is a just do problem, I think. Yeah, I guess the reason why this is a medium is because you gotta, like, because of these constraints, you gotta make sure that, like, essentially, the solution is probably the trivial solution, is just make sure you implement that trivial solution well, right? If you're lazy with this can grow even by a little bit and make the multiplication of these two, like, really bad, and same thing with this guy, right? Also, I wonder, like, no, sorting folder... Yeah. That's not really useful to sort. I want to know, okay, so essentially it's like def is subfolder. Self, subfolder, folder, right? Essentially it's just yeah, /a/b/c is a subfolder of this. So really, you just want to check if folder is a prefix of subfolder. So then it's like, is it a try? Right? Okay. Maybe it's like, if I sort the folders and then I do the try stuff. Because the point is like, if I populate the try and then I check stuff, it's like, oh, the words already exist. So obviously it's going to be like, oh yeah, there is a prefix, right? But is there a prefix that's not itself? It's making me think of like when you use tries then. Like, is this not a tries problem? To deal with prefixes of words, except these words are like slash divided and all that stuff, right? Like essentially, is there a second prefix by the time you get to your last slash? Otherwise, we can do the dumb way. For now we can just return like, folder up to length of subfolder is equal to subfolder, right? So this is unoptimized for now. To do, optimize this, right? So then we'll do for folder of folders. Oh, but this is how you get to, yeah, even if I optimize this with 2 pointers and whatever, I can't just pass in a second folder, right? Again, I gotta try stuff. So it's like I gotta get the substrings, like the point is that like they're not single letters, right? If I have like, I need to first look, okay, is /LeetCode in there, right? Otherwise it's /LeetCode /problems in there, and then there's like blah 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 up until the very last slash. The only problem is if I split on the slash sign, then I have to add those slash signs back in there, which is just a huge bummer. And like using a try, it's like it doesn't even make sense because it's like it'll just always return true with its own word, which really makes things annoying. Okay. I mean, the Ooga Booga way is just like, update your I pointer until you get to the second slash, and from this point on, like, create a whole new chunk of memory for this substring, which just sucks because it's like, am I not getting into that length of the string squared kind of situation? I could do something like that. For now, we could just do something like that. All right, it's just slash indices equal to this. For index in folder, if folder of in range length folder, if folder of index is equal to a slash, and slash indices dot append index, right? And then it's just like, for slash index in slash indices, if add to res is equal to true, is subfolder equal to false. Right, so here it's like, okay, this is at index 0, 1, 2, 3. Up to 3. Yeah, starting from index 1, so I don't include the first one, obviously. That append it shouldn't include that slash index, right? 0, 1, oh, this is 2. Yeah. Okay, folder up to there. This is what I don't like, right? It's just like, it's like O of the string every single time. True and break. If not is subfolder. Like if it is subfolder, if it is not a subfolder, then res at append folder, right? And here is like we return res. So that's something like this work. Yeah, it's just folders. So yeah, so something like this works, but is it too slow, right? Oh, it's not too slow. Oh, okay. Lol. And okay, dang, and we're beating a lot of people. I really thought this would be like way too inefficient. I thought we were gonna TLE. Okay, not at all. I thought we were gonna get into thousands of MS and all that stuff. Okay. I guess string manipulation not that bad in Python. It's just like I thought that this part, would be very slow, where it's like even if they're length of 100, right? It's like there's at most 50 slashes, and I do like length 1, length 2, length 4, length 6 all the way up to 100, right? So it's like, you know, sum of I times 2 for I in range 50, you know, 2450 times 4 times power of 10 to the 4, right? And it's like, okay, length of this guy, 8. Plus 1, like, yeah, you see what I mean? It's like gets to the 10 to the 8, 10 to the 9 range and so on. So maybe they just don't have any terrible test cases and so on. But okay, I guess that works. Which, all right, I mean, cool. We can get rid of this. We can get rid of this. It's just I'm trying to think. How would you do this more efficiently then, right? Folder and folders. I mean, I guess it's like you have to... Well, okay, one thing we can do is our solution without having to pre-compute all the slash indices, right? We could just get there as we go. Right? For I in range 1 all the way up to the length of folder, if folder of I is equal to a slash then we do this. Is subfolder is equal to false. Here we'll say folder of I, then folder up to I. Oh yeah, so if this is in folders, then is subfolder is equal to true, and here we break out of this for loop. And and now we've done this part, and there we go. So this should technically be a bit more efficient, right? Yeah, so this works, and this should be a little bit more efficient. Okay, there we go. Beats 81%. Yeah, so now we're at 57 instead of, like, you know, 131. And now we're getting close to that. So there's one big standard deviation here, I guess a small standard deviation here, and then an even smaller one here, right? So people are getting into the 15 ms range. So these are the ones that really interest me. So here we're at 81%, which is pretty good. But we're still, like, you know, it's like 15 ms, we're still like 4 away from those guys, right? They beat us by a factor of 4. I don't like the fact that I'm doing folder of I as a substring every single time. But that's like, how can you avoid this, right? I was trying to sorry, by the way. As I've been in my last 2 videos, I'm a little bit sick and my throat hurts a little bit. And so I'm doing my best to you know, like, make it as unnoticeable as possible and so on. But again, I apologize in those cases where I cannot help myself. But okay. Yeah, I don't like doing folder up to index I, right? Because this is like, you know, this takes, you know, up to O of I work, and it's like, you know, if like the string length is like, you know, up to 100 exactly, and there's like, you know, 50 slashes because you use only 1 character per folder name, it's like, you do this 50 times, and each time it's like with length 2, length 4, length 5, it's like, it's just not cool. Even if there's only 1 slash towards the end, it's like you're doing it with characters of length, like, you know, up to 100, it's like, it's still a lot of work. I mean, I guess it's just like they don't have that strong test cases, and the fact that I'm breaking early as soon as I know that it's not an option, there we go. Yeah, here I can just do if not. Valid folder if and only if it is not subfolder. if it's not a subfolder. There you go. And yeah, just again. Yeah, so we're around that 57, 59 ms range and so on. So like some people are here, and I don't know if I want to assume that it's like, oh, because it's like, there used to be less tests back in the day, or it's because they actually did something a little bit more clever than me, right? And surely they did something a little bit more clever. I'm trying to think, how would you get the same, how would you check if something is a subfolder of another, right? One way is like, you add all the folders. The thing is, if you add all the folders, like you really would rather this part be slower than this one, right? Because another way, it's like, you could add stuff into the try. You could add stuff into the try, but then it's like you have to sort folder by length initially. So you put the smallest length stuff. So we could try it, right? So this is an O of m times n solution where m is where it goes length of folder. N equals max of folder of I of length of folder of I for I in range M. Right, essentially it's like, this number times this number. Now it's like, okay, what if we do folder.sort where key is equal to lambda f length of f, right? And here print folder and return an empty array. I wonder. So yeah, so now I have them by length, right? So if I have them by length, then I can add stuff as if though it was a try. At any point after the first slash, no, yeah, because again, like this I will not delete. What I will delete is this guy. So I want to add the smallest guys first, and then when I add bigger stuff, I see, oh, there's already a prefix in there. GG, done deal. But then I'd have to do two checks, right? I'd have to first check if there is a prefix of it in there. It's just a weird way to use a try, right? You'd have to check if there's the a prefix of the current word inside of there. So essentially it's like, is there a prefix where I get to any of the slashes? It makes the problem annoying. And plus we're sorting subfolder, which would make this part, and again, and then it's like this part, it's like technically in the worst case, you have to check all the way up to the end for every single one and whatever, blah, blah, blah. And so it's just, like, even if it's like, 1 plus 2 plus 3 kind of thing, it's like, well, that would be n squared. But it's like, yeah, n log n times this. It's like log base, yeah. Like it multiplies by another magnitude of 5. Maybe it would be faster. I don't know. It's just, it would make a lot of convoluted logic, and the constant time factors of everything might make things slower. I think it's just not all that worth it. So honestly, this is a pretty fine solution. It's just, I wish there was a way to not have to do this little part here. It's like, how would you do it more efficient, right? Because it's like one idea is like you join as you go, but then it's still like the same problem. Join as you go is like, you know, you go up to the slash indices and it's like, oh, you have what you currently have, right? And it's like you only join whatever you need. Because yeah, you still have to, like, you know, index through that tiny little element. Just like, yeah, I don't like that. Oh well, okay. It is what it is. Okay, no worries. It's still an efficient solution, you know. We're beating, like, you know, 80% of people. Okay, wow, we got 60 ms exactly, 80% submissions on. Essentially, we're inside of this tiny little standard deviation curve. I wish there was a way to just not do it with folder up to I and so on. But honestly, it's fine. We have an efficient solution. It works very good. Bada bing, bada boom. That's what matters. So, okay, so as always in all my videos, I do a quick recap if I was able to solve the problem. So for this one, essentially, all that I did is like, hey, we're given a list of folders, and inside this list of folders, there might be some folders that happen to be the subfolder of another folder inside the same list of folders, right? And the way that the folders are named is essentially, it just follows, you know, basic like Unix/Linux folder naming style convention, right? So if you've never seen that before and so on, it's just this is essentially how folders are structured, with just slash meaning like the root directory, right? And so inside the root directory, there's a folder called A. Inside this folder called A, there's another folder called B, and so on, blah blah blah, etc. Right? And the way that I did this is like, okay, what we're gonna do is we're gonna convert folders into a hash set, right? So that way, it's like I can look up any single folder in O one time, and I remove any duplicates, whatever, doesn't matter. And then from then on, what I'm going to do is like, okay, we're going to have a result array that we're going to return. It'll initially be empty. And then for every single folder inside of folders, we want to add it to res if and only if it is valid. What makes a valid subfolder? Well, if it is, what makes a valid folder? If it is not a subfolder, right? So in this problem, we want to return all folders that are not subfolders of another, right? All the parent most folders that we have, essentially, right? And so essentially the way that I did this is like, okay, for each folder in folders, we're gonna just check if it is valid, right? And so the way we're gonna do that is essentially, if you take something like /a/b/c, right? For an example like this, we know that, okay, what is this a subfolder of? This is a subfolder of /a, and it is also a subfolder of /a/b. It is not a subfolder of itself, right? So what we're going to do is, okay, skipping the first slash, let's look through each slashes and get the full string up to that point, right? So here it's like after the first slash, or from index 1. This is why, by the way, in this loop, I start from index 1. Starting from index 1, so we skip the very first slash. Let's look for the next slash if there is one, right? And here we find a slash, right? Okay, so let's get the full string up to that slash, not including that slash, which in this case is just a /a. And if we see that we have another folder inside of our hash set of folders, because we have all our folders in a hash set, so we can look up in O one time if a folder exists inside of this hash set. So here up to this slash here, we check, okay, is this folder here inside our list of original folders? And if it is, then that must mean, okay, this whole thing is a subfolder of /a, which is inside my list of original folders. Therefore, it is not a valid solution, right? So in our code, I initialize is subfolder equal to false. In this case, for every single index, I look if it is a slash, and if folder of up to I, not including I not including that slash index, is inside of my hash set of folders, then I said, oh, it is a subfolder, and I break out of it, and I do not add it to my res append, because again, it is a subfolder, and we want all non-subfolders, right? And then if that wasn't the case, you know, if that condition didn't return true, then no worries. We're going to keep going and go through the find the next slashes as long as they're still there, right? So here we look at this slash over here, and so that means we get the whole string excluding the last slash, so excluding that, and then that will give us, you know, the substring /a/b, which we know, like, okay, this thing is a substring of /a/b. So then we check in O of one time if that string that would make this current string a subfolder of another is inside of our folders, and if it is, then okay, it is a subfolder, and we set it to true and break. Otherwise, it is not, and we just keep going, right? And at the end, if we look through every single slash and none of those substrings were inside of folders, then that means that every single case where it could have been a subfolder of another folder was not executed and triggered. Therefore, this whole folder file path in itself is not a subfolder of anything else, right? So in that case, it's like if we've exhausted every single possible case, and then we check, okay, if it is still not a subfolder of anything that we've seen so far, then we append it to our result array, because again, that just means it is not a subfolder of anything else. And at the very end, I just return my result array with all the non-subfolder folders, right? And again, just to reiterate this one more time, the way that I do this is essentially, it's like, okay, for something like /a/b/c, the only things that this can be a subfolder of are like, you know, all the substrings all the way up to each / except the first one, right? So like this, starting from the very first forward slash, oh, here's a substring, right? So this is like one thing that it could be a subfolder of, and then here is another thing it could be a subfolder of, right? So essentially, like, we go through every single thing it could be a subfolder of, and for each one of those things that it could be a subfolder of, we check, okay, is that a folder that exists within our list of folders? And if so, then it must be a subfolder, right? Again, the idea is just, given any folder, we compute a list of all the things that it can be a subfolder of. And then for each of those things, if none of those things that would have turned this into a subfolder, if none of these exist inside our hash set of all the folders that we have available to us, if none of these show up, then that means that this whole thing is not a subfolder of any other folders inside of folders, right? Because again, this can only be a subfolder of these things. And for each of these, we check that it is not in our list of folders, then it must be that this is not a subfolder of any folder in folders, right? And that's essentially what we're doing, right? We get all these substrings, and for each of them, it's like, oh, if it is indeed in our folders hash set, then we say it is a subfolder and we break. Otherwise, if this never got triggered, it is not a subfolder, so this will be true. And then we just append that to our result because it is not a subfolder of any other folders that we've turned into a hash at the very beginning. And then at the very end, once I've exhausted through every single folder in our folders hash set, then I just return res with all the folders that are not subfolders. So hopefully that explanation makes sense. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend.